Good morning, class. Today we're going to take a look at 10.6. Yeah, we jumped a few sections. We're going on to circles and arcs, and we'll be dealing with circles for the next couple of sections, trying to consolidate our time frame with our calendar, loss of days, and so on. So we're going to the next pertinent topic, which would be circles. You'll notice our objectives. Students are going to find the measures of central angles and arcs. We'll talk about those today. And then our next section will be on circumference and arc lengths of circles. We'll cover that in the next section. We'll actually take about 3 days to cover 10.6. Just so that you're aware of that. We'll take 3 days to cover 10.7. We'll review and take a quiz. We'll talk more about details in an email. I hope you can navigate through all of this. In a plane, a circle is the set of all points that are equidistant from a given point, and that given point is called the center. In this particular circle, our given point is P. You name a circle by its center point, so this would be called circle P by that center point at P. Now, there are a couple of pieces that we identify in here. The diameter, which is the whole way across the circle, all right, passes through the center point. So a diameter is a segment that contains the center of the circle, and both endpoints are on the circle. And you'll also notice that a radius is a segment that has one endpoint on the circle and one endpoint on the center. Now, if two circles are congruent, then they have congruent radii. Notice the radius and radii, that's the plural of radius. And a central angle is an angle whose vertex is in the center of the circle. So they've referred to angle APC, which would be this angle in here, APC. So what's the name of another central angle? Yeah, CPB. Yeah, it's kind of hard to write with this little pen. And what's the name of another another radius? Yeah, PA. And that would be a segment, or PB. And it just so happens that PA and PB put together makes the diameter. So we get that diameter equals 2r, 2 times the radius, and those are the lengths of the diameter and the lengths of the radius. All right, now, it's essential that you catch this piece. You can find the length of a part of a circle's circumference by relating it to an angle in the circle. So arc STR is a major arc, and arc RS is a minor arc. One other type of a circle, or of an arc, is a semicircle. That's halfway around. So in this, all the way around from RT, you get a semicircle. So arc RT is a semicircle. And STR, that is all the way around, okay? STR is a major arc. The minor arc is the lesser one, SR, or RS, is a minor arc. Now, can you picture from this picture, can you get another minor arc? If you said TS, you're correct. If you said SR, you'd also be correct. Those are both minor arcs. Another major arc, now that's bigger than a semicircle, so that's better than halfway around. They said STR. Can you think of another one? TSR is only halfway around. You'd have to go further than that. So STR, you could go with SRT or RTS. That would work. RTS would be another one, and there are more. Okay? So, naming arcs. What are the minor arcs in circle O? There are a ton of them. Let's go with 4. Okay? So, we could go with arc AD, which is this piece, and we could keep going all the way around. So, arc DE, We could skip one and go from CA. And I already said DE. And we could do EC. Come back and catch arc EC. What are the semicircles of O? Okay, now if I go to the left of A, I would go clockwise, ACE. That would be arc ACE. Going around this way. All right. Okay. And if you went around this way, that would be arc ADE. And that's how you're going to distinguish between two semicircles. You're going clockwise or counterclockwise, ACE or ADE by that middle term, and that's why we add a third letter in there to make that distinction. What are the major arcs in this one? Major arcs would wrap all the way around past the half, so you could call that one arc EAC, or you could even call it EDC. Just make sure you go all the way around and not just EDA. And you could also use, you could start at this side, and you could call that arc so DE, you'd have to go all the way around to A, though, DEA, or DCA. Now, turn those around, you got different names, but the same arcs identified. Let's go on. Minor arcs of circle A. Give me two. Two minor arcs. Yeah, PQ, that would be one. That works. And another minor arc. Look, RQ. Okay, it's a little bigger than PQ, but it's still not a semicircle. Okay. Now the next one is the arc measure. The concept here is the measure of a minor arc, the measure of the minor arc, is equal to the measure of its corresponding central. Now this is the minor arc right here. So arc RT is equal to the measure that's down in here of this central angle, measure of angle RST. And they're both 50 degrees. Okay, so we see that that one says 50, but if you came on the outside, then that means that this one out here is also 50 degrees. Now you could find the major arc, which is this guy out here, okay, by taking the entire circle, which is 360 degrees, most of us remember that, minus the arc that we did identify, which was RT at 50, and if we took the 360 minus the 50, we get where they got the 310. It's the remainder. And that would be my major arc. Moving on. Feel free to pause at any time you need to. The arc addition, excuse me. This is why they don't want us to meet together anymore. The arc addition postulate says that the measure of an arc formed by two adjacent arcs. Adjacent means they're butted up against each other. So, measure of arc AB and measure of arc BC, those are adjacent, as shown here, gives us then a total measure of arc ABC. So it's like arc going around the way of B to get to C, measure of arc ABC. Find the measures of these arcs. All right, so in our diagram, BC, well, the central angle BOC is 32. So the minor arc is also 32. So we'll call this one a 32-degree arc. What's the BD? Arc BD now, oh, that's BC, which was 32. Sorry, we'll try that again. 32 plus CD, which is 58, and if you add those together, yeah, you do, you get 90. So that is a 90-degree angle in there. Interesting. Measure of angle ABC. Now that's this one all the way around here. So that's a semicircle. And the length of a semicircle is 180 degrees. What's the measure of AB? Well, I have to get rid of a couple things here. AB, okay, now we're going to have to use the measure that we do know, the semicircle, which is 180. And we'll take away this piece right here to find AB, which is what's left over. So we'll take away the 32, and the measure of arc AB would be 180 minus 32, 148. Oops, I lost my pencil there. Okay, 142. We got one more here, and then we're done. So what's the measure of PR? If you match it to this central angle, PCR, at 77, the measure of arc PR is 77 as well. Well, I hope you found this to be helpful. Good luck on the homework. The homework will be found in Math Excel. It is set 10.6a. Good luck with it, and I'll see you for 10.6b on the next one. Okay, see ya. Bye.